Hello, welcome to this Unity tutorial video where it's a tutorial but it's also going to be a bit experimental. I'm just going to creatively code as we go along, and in particular for Josip, hello again. I'm going to make another video for you to do two things. We're going to look at how to create like a collection of objects or an array of objects or a stack of objects, and then remove them. So what's happening here is you'll notice I'm kind of causing objects to rain down. What's happening there is every time our laser hits an object, we are destroying it and then creating a new object. But the way you would actually do that is not literally. I'm sorry, I think there's a load of baby, or this is maybe good news, there's lots of baby birds making lots of squeaky little squeaks over there. So if you heard that weird noise, that's what that was. If you can't hear it, then I've just described it. Right. So what you would do is you wouldn't actually destroy a game object and then initialize it or instantiate it at runtime, because that will cause things to slow down. So what I'm actually doing is just deactivating those objects. So removing their physics and their rendering from the scene, and then I'm just placing them in a random position up there somewhere. The other thing, so that's basically how you would what you would do. I'll show you exactly how to code that in a moment. Also, it feels like I'm kind of like hoovering up the the cubes with my laser. Oh yes, speaking of the laser, I think you mentioned the aim was a little off, was a little bad. So there's a different function you can use to improve that. You only have to add about 6 lines of code to our existing ray gun laser code. This is where we're using the line renderer to create a laser to kind of fix that. If you can see on my screen, the laser is pretty much exactly where our mouse is. Obviously, if there's a line of sight issue, if I'm clicking to this hill and where the laser begins at the front of our drone, if that can't see, beyond that hillock, then obviously it won't reach where the mouse is. Although if there's nothing in the way, it will perfectly align with where the mouse is. And again, there's like a little hill here, so it's not quite hitting. Right. So what you could do is when you hit an object, you could basically make the object disappear. Just make it invisible. Don't actually destroy it, and then you can put it wherever else you want, and then reposition it and make it appear again. That's very efficient compared to destroying and creating objects. So I'm doing that using a stack. I've never used a stack before, but I was just reading about this, and apparently stacks are a lot faster than even arrays. So I've got 1,000 objects here, and I'm recording. I've just deleted the camera, so this is a time to stop, and it's nice and fast. I'm just gonna, while I'm talking, let me just put on the screen the improvement to the mouse. Yeah, I'll talk about this now very quickly. If you're not interested in how to do this, sorry, skip ahead. This is more for Josip and whoever looked at the previous video where I created this line renderer laser. Instead of saying something like, oh, sorry, I'm just losing where I am. There we go. Instead of putting a mouse position equals input mouse position, and then last time we did something like this, we then said the Z direction of them, the Z component of that mouse position, because we're taking from 2D space and projecting into 3D space. So there isn't a Z component from the 2D mouse position. We say that is something like 300F. And then we used a camera screen to world point function. So instead of that, what we're going to do is just grab the mouse position. So that's its X and Y, nothing in the Z yet. And then what we're going to do is create a new ray, a physics ray. So we do this in the original code to draw a ray from the front of our drone to wherever the mouse is projected to. So that's all going to stay the same. But before we do that, we're going to create a new raycast, and that's going to be from the mouse position on the screen into the scene, using screen point to ray to create our ray. And then we're going to pass in that ray, I've called it laser ray, into a physics raycast, and we're not going to set out any distance, and we're just going to create another raycast hit. Before we called it hit, this one's going to be called laser hit, and that's going to be outputted when we cast our ray. If it hits anything, the endpoint is just the laser hit point. If we don't hit anything, then we can just say it's the laser ray, so the ray that's being cast in, and we're going to use get point, and we'll just say 30 units into the scene. And that's it. So I'll just highlight the code. There we go. that should project the mouse position into the scene with more accuracy than we did last time. Okay, so also what you talked about. Let's go and deal with our objects. I think I'll just run this again. Have a swig of coffee. I think in your question, Josip, you asked about the objects like moving past your ship or your character, and then at a certain distance, you wanted them obviously to be taken out of the game because then they'll be using up too much memory and it'll slow down your game. So again, what we would do is not destroy the objects, but kind of turn them off, and we can use a function called set active, and you just say set active equals false or set active false, pass in as an argument, and then they won't be rendered anymore, and they won't use up any physics, etc. Their updates, I don't think, will run. I think actually, if this is just incidentally, if you're using any objects as triggers, then and you set them to inactive, their trigger will still work because it might be useful to use the trigger to like set them back to active, so they're not completely switched off. They're not destroyed or anything if they've got a trigger on. So what we're going to do, I think I'm going to get rid of this terrain, so it's kind of more like we're in space, and then I'll get these cubes kind of like moving past me, and then what we're going to do is say I'll show you how to measure the distance from the ship. That could be a way to remove them, or you could, if they're moving, say, along the z-axis, if they get to like minus 3000 or something, or minus 200 or something, then you could switch them off and then make them reappear at a new spawn point. What else? So basically we're gonna set up prefabs, put them into an array or a stack, and then manage them from there. Okay, right. Let's go and sort that out. So here's my assets folder. So I want to kind of start this from scratch, don't I? So I will turn off my spawner, and we'll create that from scratch. Also, I'll turn off my terrain, and actually, let me just turn on the spawner for a moment. I'm just going to see. No, I'll turn it off. Let's just get going. Let's just see what we've got in our scene at the moment. Good, so we've got nothing. So I just want to pause and have a look at the transform to see if I'm falling or anything. Oh, I have got a rigid body and I am using gravity. So yeah, I definitely want to switch that off. Oh, it looks like I create a rigid body from a script. What am I using? I'm using my pilot script. Let's just bring that up. Okay, so straight away I'm adding a rigid body to myself. So you know what? So I don't have to change my script. I'm just going to say this get component rigid body use gravity. Oh no, use gravity equals false. So that's how to turn off gravity, by the way, which is quite fun. You can turn off and off, on and off gravity if you need to. Another thing you can do is, just while I'm spontaneously writing things, you can get hold of the rigid body again, and you can affect the drag of an object. If you're wondering if you wanted to go into, say, some water, and then have that effect of being suddenly in a very like viscous, like slowed down medium, then you could, I don't know, times the drag by, multiply the drag by itself by like a factor of 10, and that will really slow you down, or a factor of 4 or whatever. And then when you re-emerge from the water, or I don't know, the gravity well of a star or any kind of like cosmic object, then you could use the drag, and when you escape it, return it to what it was before. So maybe at the start, record what your original drag is, and then re-establish that when you escape. Okay, so all I was doing is turning on turning off the gravity so I'm not falling or anything. Right, let's go and spawn some objects. So first we will create a prefab, if you didn't know how to do that. So my objects, I'm just imagining kind of like a sphere with something in the middle. So it's kind of like transparent. I think that would look kind of cool. Right, I should have prepared some asteroids from the asset store. So this is going to be the center of my sphere. So let's make this very, you know what, I'll duplicate it, Control D. So I've now got 2. So I'll call that one outer, this one inner, and I'm going to make my inner have a scale of 0.3, so something like a third of the size. I just got that mic. I hate it when this microphone thing comes up. There we go. It's gone away. For the inner one, you know what? I can remove component. Now that's weird. I've got my menu coming up down the bottom. What's going on there? Anyway, we're going to make it bright pink, I think. So I'm going to have to create a new material. I shouldn't have called this a tutorial. It's called like a creative coding, rambling, spontaneous thing. So we'll call this pink matte. And then I want that kind of bioluminescent. So the shader I want to use is unlit. So it's just a pure color. Or, what else have we got? I haven't looked in here for ages. What I'm thinking of is, oh yeah, by the way, mobile materials and shaders and things will optimize your code. They're very efficient. Vertex lit, nature. No, just looking for. It's got its own. It's like its own light source. Maybe it's in FX flare. Well, let's put a flare. I don't know what that is. I've never used a flare. It doesn't look like it's got colour. I'll just leave it as it is. Okay. Although we might need a texture. Let's go. I guess if you wanted a colour, you'd have to use texture's colour. I'll use a default particle. Right. Anyway, so that's our inner sphere. And our outer sphere, we want to make that transparent. So we're going to make another material, and I'll call that trans matte. So we'll go to fade, and then we'll change the albedo. We'll change the alpha. That's the transparentness, opacity. I just realised why my object's not changing. That's because I haven't yet applied transmat to our object. There we go. So we can go about that, and then make it kind of blue. Okay, I'm happy with that. Right, so we've got a little object. We want to parent the inner to the outer. So now when we move this object, it all stays together. And now to make it into a prefab, which you may or may not know, we drag that from the hierarchy into our assets folder. And we've got this, a prefab, so we can delete the object in our scene from our hierarchy, and the prefab, of course, stays here. It's not the same object. but now we can make lots of prefabs by just dragging them into our scene. So we've got everything we need to spawn some objects. Right. Let's create a spawn script. So we'll call that a baby farm. Baby farm. I think I've called a spawn at a baby farm in another video. So what do we want to do? We want to create a public game object variable where we can store the prefab that we want to spawn in. And we also want a variable for how many instances of that we want. And then we want to be able to kind of randomly position them and then also store them in an array so that we can, or a stack, so that we can deal with switching them on and off. Right. So we won't need collections. We'll need collections generic if we use a stack, I believe. Okay, so first, oh yeah, let's delete our comments. Traditional. And let's make a public object, and that's going to be a game object. I'm going to call that prefabby. That's our prefab. Right, and we want another public integer, how many, and we can set the default to 1,000. Actually, it's probably a good idea to set defaults to about 10 in case it's very bad code and then it slows down your game. You've only got 10 to deal with, not 1,000. Okay, so let's just see if we can spawn them from the start. So we're going to create a for loop for int I equals 0 while I is less than how many, increment I by 1 each time, and then we're going to say let's create a game object. I'm going to call that our newborn object, and it will equal instantiate our prefabby. There we go. Right, we could just write game object instantiate, but if we store that, if we assign it to this newborn object, it means we can get hold of our object and change its position. And we're going to use random inside unit sphere. So we can kind of spawn them at a random point, in an imaginary kind of sphere shape. How do I get to that? Oh, inside unit sphere, here it is. And then I think we just put how big you want that sphere to be, its radius. So I don't know, 42 units. It's still red. Something's gone wrong. Oh, okay. So units. Oh, it's a unit sphere. That means it's only going to have a radius of 1. So then we scale that up by 42 here. There we go. Now, that's still going wrong. Why is that going wrong? Oh, okay. I thought you would need brackets after that. Is it not a... Who knows? Who knows? We'll find out. Right. Now, it might not make sense in that, well, where is that going to be in space? It's going to start from 0, 0, 0. It might be a little better to say its position equals origin point plus this vector. Right, so we'll create a private vector3 for our origin point, and maybe in start we'll just say origin point will be wherever this transform is, this script is. So baby farm isn't actually in the scene yet. I'm imagining I'm probably going to attach it to an empty game object. So just a invisible ghost of a script inside our scene somewhere. So we'll say origin point equals this dot transform position. And a position, that will work because a position, let's write this, a position is a vector 3, smiley face. I'm going to make my code slightly bigger. Hopefully that's okay. Hopefully that's even better. Right, we've saved it already. Let's get our script into the scene. And I want it to look more like space, but I don't want to fiddle around with aesthetics too long. So we go to game object at the top here, and create empty. It's right at the top. So now we've got this empty game object, and we'll call it, this is like the birth of things. The birth of things. You could call it your game manager or your spawner. That would make more sense. I'll call it, oh no, what gives birth? A mama. Mamas give birth. I'll call it mama. Right, now we want to attach just select mama and then make her a baby farm. There we go. And now we can see our public variables, prefabby and how many. So we want to drag our sphere thing into a prefabby. So now it can spawn something, and how many we'll keep to 10. Okay, let's just run the code. I can't remember if it's going to do anything yet. I think it does instantiate some things, and it puts them at random positions. So let's have a look around. Yeah. Oh, great. So it's created 10 random objects around. Yes. Oh, and I've got my laser. Can I actually destroy these things yet? Can I destroy them? No, because I keep deleting my camera with my laser. That shouldn't happen. Oh, it's because my drone's got a rigid body. Let me go and deal with that. So in laser. Okay, this is kind of like a sneak peek to what we'll do in a little while. In this script, which is very similar to the script I made in the previous video, when we cast a ray from the front of the drone or the ship to the endpoint of the laser, if we hit a collider, we push using add force its rigid body, so we interact with it in a physics way. And then all I've added is the hits transform, and to get hold of the game object, we just write game object little g here, and then I'm setting its activity to false. So that's how to turn off a game object. But I don't want to do that if it's our camera. So I can say if hit transform, if hit. Why is I've just noticed my IntelliSense, my autocomplete's not working very well. Why can't I just say if hit? It just brings up the errors for some reason. Anyway, if hit, can I say transform game object name, if it equals droney, I suppose I should say if it doesn't equal that, then you can, these brackets aren't essential. An if statement will complete the next thing that you've the next statement that you've written, but just to make it a little clearer, let's just make sure I've got that name right. Droney, yep. So if it doesn't equal droney, then you can set it to inactive. Right, so I'll probably forget that I've done that and everything will work fine, hopefully. Baby farm. So yes, we are instantiating this many objects, and oh, we could give them rigid body. That's probably not a good idea because using objects or dealing with objects that have rigid bodies is a lot more costly. Will slow things down. But let's just try it out to see how slow it is. So I'm going to add component physics rigid body, and we'll just turn off gravity. Oh, we could say it's kinematic, so it's not that might improve the speed actually. And let's make 2,000 of those, or 2,222 of them. And hopefully we'll get like this sphere. Oh, I might be trapped in the middle of it. Oh well. Yeah, that looks great. And it's working nice and fast. Frame rate is okay. So I can actually hit these objects now, and because I've got a rigid body, I am getting some physics interaction. Oops. Let's see if I can. Yes, I can destroy them by, well, I can set them as inactive. My chihuahua needs to go outside. Excuse me 1 second. I've released the hounds. Right. Okay, so I think what was happening in your script, these things were like moving past you. So let's get an array set up so that we can use the array to iterate over all our objects and like move them, so we don't have to give them an individual script. That's one way you can get them to move, is give them an individual script that moves them in their own update loop, update function. But having one script to control them all, I think that might be more efficient. So, and we could do it in baby. We could do it in baby farm maybe. Let's try and be sophisticated. Baby farm is a script that spawns objects, so it shouldn't do anything else. The way we should organize this like project is to have another script that deals with moving the objects and other things. So let's just see if I can coordinate that. It just requires that some variables you need access to between scripts, so that the scripts need to be able to talk to each other, but it's useful to practice that anyway. So we'll call this, I'll call those things droplets. Droplet manager. Here we go. And I guess we could attach that to Mama. There we go. And right, let's open up Droplet Manager. And in here, this is where we're going to create our stack. So it's not going to be an array, it's going to be a stack. So we want private stack, and it's going to be of type game object. That's our droplet objects. They're all going to be game objects. Okay, I think that's done there. No, that's wrong. Do I have to now set equals? No, that should be fine like that. Let me just go and have a look at my previous code where I've created a stack. Oh yeah, we've got to give it a name, of course. That's what I was doing. Right, private stack, and we'll call that our droplets. There we go. It's conventional to pluralize an array name or a stack name or a queue name, any kind of like variable that has lots of things in. Pluralize it so you remember that it is like a container. So we want first to populate this stack with our droplets. it makes sense to kind of do that here, where we're instantiating them. So I guess this script should pass our newborn over to the droplet manager. Okay. Can I make... Let's just do this in a lazy way. Public, I'll make that public, and then our baby farm can get hold of that. So let's give it a script. How do I find that script? Do I attach it? Can I just say this get component droplet manager, which is weird. Usually when we get a component, it's going to be the transform or the rigid body or the renderer, but if we've got a script attached, let's just bring that up. Yeah, if we've got a script attached as a component, we can also grab that component as a component. And then we can access its variables and functions. So there we've got our stack, our field, droplets, and because it's a stack, let's just bring this to a new line. We can add an object to that by using push. Basically, push, it adds an object to your stack, and pop removes it. So we're going to only push them all at the start of initialization, instantiation, and then we don't need to ever remove them because that would slow down again. We're just going to turn them off and on. But having them in this stack, we can iterate over them and find ones that are inactive. When we need to spawn a new one, we can iterate over, find one that's inactive, and then just say that one's now active in a new position. So droplets push, and then we just place in our newborn. There we go, lovely. Right. And I think this is kind of bad because this variable, this field, this stack should be private, and only this script should be able to change and manipulate things. Else, why have two different scripts? That's the point, but I can't think quickly enough to do that in a better way. So let's just write a comment. So we know what we're doing. Add the newly spawned object to the stack. Smiley face. Okay. Then in Droplet Manager, we'll do nothing for the moment so that we can show a difference. What we'll do, we'll generate loads of them again, and so that we can see the difference. Oops, something's going wrong here. Object reference not set to an instance of an object. At assembly, line 27. We haven't had a bug yet. This is good. What's going on? Right, so it can't get hold of droplets. Why not? What's going on? Oh, I haven't really created it. I need to say droplets equals new stack game object. There we go. Let's just see if that now works. Oh, if this works, that'd be perfect. This is exactly the kind of bug that might come up when dealing with a stack. I'm new to stacks as well, so I don't really know what I'm doing with them. Yeah, so that's worked this time. So all I want to do again, I know we've already achieved this part, is hide as many of these as possible. Remember, they're not really being destroyed, we're just setting them to inactive. This is not going to work, there's too many of them. I'm not going to destroy them all, by the way, I was just going to destroy quite a few, just to make the point clear that we are not reactivating any of them. They're just being removed, we're not setting them to active again. So how would you do that? One way you could do it, having done that, I've just seen that's kind of pointless. Having done that, what we could use is the update loop on our droplet manager. And we could use a foreach loop. So we could say foreach, and then we're going to say the game object, we'll call it n, in droplets. Do this. So this is just a loop, like a for loop that goes around, and it's basically going to iterate over our droplet stack, and for every object on that stack, do whatever we write in here. So let's apply this to all of them, and they're all going to be referred to as n. So that's just going to be each object, each little droplet that we've got in our droplet stack. So we're going to say if n is active, my autocomplete is not working and it's slowing me down a little bit here. Let me go to my previous script where I've done something similar. Active self, set active true. So it's active self. There we go. If you can say if it is not active, then n active self set to true. I've forgotten what to do. Spawn monkey. Set active like that. Capital S. Why isn't it like that? It's gone green. Yeah, active self. There we go. So that's saying if it's not active, then set active to true. So it'll reappear. Now, I don't know if that's going to be very apparent when we delete things. Before, well, we know it's going to work. Oh, there's one, yep. Oh, we do know it's going to work because, oh, this is, I've almost done this cleverly. It is going to work because they're going to reappear exactly where they were before. So it's really easy to check that this is going to work. I didn't realise, I forgot that we haven't repositioned them. So, oh, that's worked out very well. Okay, so that's working straight away. So what we want to do before we set it active again is reposition. So that, of course, is a function that doesn't yet exist. So void reposition. So I'll reposition this thing. So just to illustrate again, so this is an update loop on the droplet manager. So it has access to all of the droplets in the stack droplets, and every update loop, it's looking at all of the 1,000 or 2,222 of them, and it's saying, are any of them inactive? If they are, let's go and reposition them and activate them again. And you can see it worked seamlessly. It's very, very, very fast, even though we're dealing with thousands, literally thousands of objects. So to reposition it, first we need to pass in n, and this is going to be a game object. I'm going to call it n. Again, we don't have to, and we'll say n dot transform position sorry position equals, and do we have origin point in this? No, we don't have origin point. Damn. We should have just done all of this in the baby farm. Let's go and grab that origin point. So private vector3 origin point, and we'll say origin point equals this get component baby farm and we're going to get hold of its origin point. We can only get hold of it if we make that public, which again is very bad programming. We shouldn't be making all our variables public. That means any script in our project can get hold of that variable and change it. Why that's bad is because if our project develops and gets very complicated and we get some strange bugs, like we don't know why things are changing or going wrong, then it's going to be really hard to track which scripts are doing what with what variables. And so what should happen is each of your procedures, each of your behaviors should be like self-contained, and I'm doing the opposite of that, but it's going to be a tiny project. So it should be okay. We should have all done this in one script, but it's kind of nice to see how to exchange information or send messages between scripts. Right, so we've got our origin point, and we determine origin for spawn position from the spawner itself, and that's the baby farm. Just write that little comment so we know what's going on. Here's our update loop. So here we're check to see if any object, well not any object, any droplet is inactive. If so, reactivate and give a new position. There we go. And we're going to reposition it here. So it's going to be position equals origin point plus random dot unit sphere times 42f. And because my autocomplete wasn't working again, let me just go and copy inside unit sphere. There we go, that's what I wanted. Inside unit sphere. That's looking okay. So again, if you wanted to position them, say, in front of the ship, yes, which is what we want to do. So let's just go and check our script so far. So after this, we just got two things to do. We want to move the droplets, get them moving past us so it looks like we're in space or something, and then we only want to respawn them in front of our ship. Very pleased with how fast this is. I think it's because they have got rigid bodies, but they're only kind of like kinematic. Now, I'm not getting any error codes, but it's kind of impossible to see any... Oh, I think I saw one respawn there. Oh, and as we go out, we can kind of see that it's a unit sphere. That's really nice. Right. So, we'll do an asterisk and a forward slope. I should have turned everything green. What's going on? Oh, there we go. So, by the way, if you've never seen that before, slash and an asterisk and a slash, it just says, could I comment out everything in between that? That's sometimes handy. So this time, we'll leave that at the bottom. This time, reposition to front of character. Reposition to front of character. So we need to go and get hold of our character. So we'll have a public, and we only need to know about the position of our character. So we only need a transform really. So some good coding advice maybe is, if you're getting hold of some data, only get hold of what you actually need. So we only really need the transform. We don't need the whole game object. We could get hold of the character's game object, then its transform later on in the code, but we could just grab its transform. So we'll call that subject or target. No, I'll call it subject. I'll call it me. No, I'll call it the player. I'll call it the player. Right. Public transform player. And should we find that in code? Yeah, let's find it in code. So we'll say player equals game object find, and I think we called him Droney, and we don't want the whole game object, we just want the transform. Okay, so as long as your game object is called whatever you put in there, it will find it. I've also made it public. So back in the editor, on Mama, yeah, it's looking for our player. What you could do is just drag Droney there, and it'll overwrite the default, which we haven't got. We have no default here. But at the start of the game, it will go and find Droney again, which is kind of now redundant. So I've just showed you two methods to basically populate our player. You could make this public and drag it from your hierarchy onto this field here. Or you don't need to do that at all. You could just make this private, and then in your start function, just write populate it this way or assign it this way. Player equals gameObject.find, and then pass in a string of the name of the object that you want to find. And just remember, that will return the game object, but that wouldn't work. It will create an error because player is not a game object, it's a transform. So we just need to put dot transform to return the transform. Right, so with that, in our reposition, we can now say n transform position equals, we can say our player, and remember that's a transform, not a game object, so I don't have the right transform here. It's going to be its position plus, and then I guess we want to go forward, so that's relative to where we're pointing towards. So that's going to be players dot forward times, and then how far in the distance. So we'll write how far away, and then we can set that in the editor, which would be more convenient. So back up at the top, public how far away. Oh, that's going to be a float. It could be an int. No, it should be a float. When you're dealing with vectors, as we're doing here, they usually like to deal with floats. It might work as an int. You can experiment with that at home. Float far away equals, and we'll put it 100 units ahead. And yeah, so I suppose whenever we spawn one, it's going to be exactly yeah, 100 ahead, so they're all going to be, oh, that's really nice. I was going to say they're all going to be in the same position, but of course they're not. It depends where we were pointing when we destroyed it. And when I say destroyed, remember, we are only deactivating it and reactivating it. So that's definitely working. And notice this is very efficient because we can keep on doing this forever. We've kind of created a nice mechanic now where we can keep destroying these and they'll be reposted, repositioned ahead of us forever and forever. And it should work in all directions. Yes. Okay, so I think the last thing I'll do is just get the objects moving. So in our update, we're already iterating over all of our objects. So I guess after we've checked to see if it's inactive, we could then say else ends transform. We could translate it. We want to go, no, along the z-axis, or maybe they should all go towards the player or whatever. I'll just say vector 3 back times speed times time dot delta time. So vector 3 back just means going the opposite, so it's negative 1 on the z component of 3D space. Something like that. Okay, so we just need to go and create our speed. I don't know how fast or slow to put that. Speed equals that. Now, to do this more sophisticated, what if you wanted different types of prefab? Then your spawner will deal with that. Oh, it looks like my ship is moving, but of course it's just these guys. That's a really leisurely nice speed, by the way, 1. And that, because I've used that time delta time, that'll be exactly the same on your computer or anyone's device, so long as they can run it at all. Okay, so Josip and whoever else needed this and has watched this video, we've got all the tools, I think, that you need to deal with like object spawning and things like that. Oh yeah, as I was just going to say, if you needed to, say, have the objects moving at different speeds or have different behaviors, then you could add a script to the prefab itself to determine its own behavior. I'm sure it wouldn't slow things down. I've definitely done that kind of thing in the past before and it's been fine. Okay, do put any more questions in the comments and things. Sorry for the rambling nature of this. I hadn't planned it. I was just kind of making it up as I was going along. There you go. Thanks very much, and good luck.